Okay, and the last part of this is to find the speed of the particle. And speed actually comes up more when we talk about vectors, but it's literally just a formula, so I'm going to introduce it to you right now. So maybe it'll be easier to memorize down the road. But speed, and you may know this from physics, is the square root of x prime of t, the quantity squared, plus y prime of t, the quantity squared. So if I want to find the speed at t equals 1, then I would need to find the square root of x prime of 1, quantity squared, plus y prime of 1, the quantity squared. And there are lots of parentheses involved there. But when you type that into your calculator, you get 4.105. And on the AP exam, they would expect to see the speed formula with, like, they would expect to see this bottom line, square root of x prime of 1, quantity squared, plus y prime of 1, quantity squared. And I put the squared in the wrong spot. Should be right there. And then they would expect to see the answer. So speed is really nothing more than knowing the formula. But we'll talk more about that when we get to vectors. Okay, number 2. This one actually does not require a calculator. And on the AP exam, they did not let you use a calculator. So we've got a particle that moves along the curve that's defined by the equation y equals x cubed minus 3x. The x coordinate of the particle, x of t, satisfies the equation dx dt equals 1 over the square root of 2t plus 1, with the initial condition that x of 0 equals negative 4. So find x of t in terms of t. So what do I need to use that's given, and what do I need to do to it? Good. I need to integrate dx dt. So I'm finding the integral of 1 over square root of 2t plus 1 dt. All right, integration never goes away. How am I going to integrate that? Do what? Okay. Yep. U equals 2t plus 1. So du is 2 dt. So I need a 2 and a 1/2. So the 2 dt is my du. I have 1 over root u, so I can think of that as u to the negative 1/2 du. A lot of people want to integrate that using natural log, but natural log is 1 over u, not 1 over the square root of u. Okay, how do I integrate that? Okay, u to the 1/2. Is that it? Plus c square root of 2t plus 1 plus c. You always need to think to yourself, is there any way that I can find c? Okay, yes, there is a way to find c, and no, the plus c is not under the radical, because what we got was u to the 1/2 power, and then plus c after that. All right, so yes, I can find c because I know that x of 0 equals negative 4. So when I plug in a 0 for t, that should equal negative 4. So therefore, c equals negative 5. So x of t is the square root of 2t plus 1 minus 5, not under the radical. All right, find dy dt in terms of t. What does dy dt really mean? The derivative of y with respect to t. I can take the derivative with respect to anything, right? Yeah. Okay, so if I want to take the derivative of y, I'm going to use this equation. Okay, and it needs to be in terms of t. So I've got two options. I can take the derivative of y, which is in terms of x, but I can take the derivative with respect to t, and then I can change everything to t's. Or I know that x of t is this thing that I found in part A, so I could substitute, I could fill in x of t up there for my x's first. So I can either take the derivative first, then plug in my t's, or I can plug in my t's and then take the derivative. Yeah, taking the derivative first would be much, much easier. So what's the derivative of x cubed with respect to t? 3x squared dx dt, right. And then minus the derivative of 3x is 3 dx dt. And in terms of t means that the only variable that I can use is t. So right now I've got a variable of x, and I've also got dx dt. So both of those need to go back in terms of just t. To make this a little bit simpler, I'm actually going to factor out the dx dt and write this as 3x squared minus 3 dx dt. Okay, so instead of the x, I'm going to use the square root of 2t plus 1 minus 5, quantity squared minus 3. And then what can I write for dx dt? Right, 1 over the square root of 2t plus 1 that was given to me from the beginning. So not a hard problem. You know how to take the derivative of anything with respect to t, and then you're just plugging stuff in. And part A was really just integrating. And then part C is find the location of the particle at t equals 4, which is really the same thing as finding the position. Right, location and position, exact same thing. So once again, we're looking for an x value and a y value. How do I find x of 4? Plug it into your x of t that you found in part A. So you get the square root of 9 minus 5, which is negative 2. Okay, now I want to find y of 4, but 4 is a t value, and my y equation is in terms of what? X. Good. You could plug the x into y of x. Basically, when t equals 4, x equals negative 2. So I would want to be finding y of negative 2, which is negative 8 plus 6 from the given y equation. So negative 2, negative 2.